Okay, when we're talking about sound energy, it's important to remember that those vibrations can move through solids, liquids, and gases. Take this table, for instance. This is a solid. It's hard. And if I take my fists and I bang on the table like this, and someone sitting at the other side of the table, they're going to be able to feel those vibrations through the table. So not only will they feel it, but they can also hear those vibrations moving through the air. So that's an example of the vibrations moving through a solid and through the air, but can we see those vibrations moving through the air? And the answer is no, not really, unless you have some sort of visual like this.
Here I've made a box and a cup with materials that you might have at your home. Right here I have saran wrap pulled tightly and a balloon pulled tightly, and they sound kind of like a drum whenever you beat on them. And then on top I have lightweight objects like rice and these pom-poms. You can also do sands or small pieces of straw. But what I'm going to do is I'm going to take a metal can like this with a metal spoon, and I'm going to be hitting the can. And those sound vibrations are going to be coming from the opened end of the can, and we're going to see a visual of these lightweight objects moving and bouncing. That's because the vibrations of the sound are moving through the air and they're moving these objects. I'm not going to be touching anything over there, so we can't really say, oh, Miss Bell, you're the one who's moving these things. No, really, it's these sound vibrations. Here we go. As you can see and hear, those vibrations are able to move through the air at a strong pace, and they are able to move these lightweight objects with ease. It's not difficult for that to happen. With this experiment demonstration, we're going to visually see sound vibrations moving through the air and then through water. And by doing so, we're going to be using a tuning fork. So we're just going to hit that tuning fork, which we're going to hear the sound first. And as those vibrations are moving through the air, I'm going to then place the tuning fork in a petri dish of water. And then we're going to see science happen. Those sound vibrations that are moving through the air are going to then move through the water, and we're going to see ripple effects. We might even see water jumping out of the petri dish or collecting in little balls. But we get to use our eyes and see that sound happening in real life, when normally we can't see the sound moving through the air. We can't see those wavelengths. But with a demonstration like this, we get to use our eyes and our hands and our ears to make it happen.
So with this type of experiment, you're going to need a tuning fork, something to hit the tuning fork, like I have right here. You're going to need some sort of dish that's flat. I just have a clear petri dish, and then you're going to need some water, and you'll need to fill your dish with water so that it has a good amount of volume in there. You can even play around with different types of liquids, or coloring the water with food coloring to kind of see the different variations of this type of experiment. Let's get a little bit closer so that we can see those vibrations going through the water. I have my tuning forks right here. I have one in my hands, and I'm going to just hit the tuning fork so we can hear what it sounds like before I ever put it in the water. And now I'm going to hit it and then quickly put it into the water, and we should be able to see those vibrations moving the water and making ripples. Here we go. Okay, let me try a different tuning fork to get a different sound. It's a lower pitch, lower frequency. Let's see if that looks any different. And let me try another one. Let's go with this one. This is what it sounds like. And now I'm going to place it in the water. Whoa! That was pretty cool. And let me go with this one right here. This is what it sounds like. And this is what it looks like when those vibrations are going through the liquid water. Ooh, I'm making a lot of splashes over here. And because Miss Bell just wants to play around, because that's what science is about sometimes, I want to put some red food coloring in there and just see what it does, if anything at all. Here we go. Oh, so cool. The only thing with this is if you use food coloring and it starts squirting colors all over the place, you'll need to clean it up pretty quick because they can stain the surface of tables pretty bad if you don't clean it up. Oh, I didn't hit that one very well. Let me try again. There we go. Whoa, that made a whole swirling effect. That was so cool. You can even play around with this. You can maybe play with the timing. If I hit it and then put it into the water as soon as I hit it, you can see what that looks like and make those observations, versus you can hit it and then wait 2 seconds and then put it in the water and look at those observations, or hit it, wait 4 seconds and put it in the water and see what that looks like. So you can play around with this a lot. Hit it softly and try it. You can hit it hard and try it. You can hit and then put it straight into the water, or you can wait 1, 2, 3, 4. And you can do all sorts of experiments with this. So to sum up everything we talked about and observed with those experiments, we know that sound comes from when anything produces vibrations. And those vibrations can move through solids, liquids, and gases. And
we can hear the sounds by using our sense of hearing with our ears. The sound travels in waves. The waves can be really low and slow like this. That's a low pitch, low frequency. Or they can be really high like this, and that's a high pitch, a high frequency. And we talked a little bit about volume. If I talk like this, you can't really hear me. But if I raise my voice like this and I talk really loud, that's a high volume. Sound is one of the coolest energies to study and to test out and to observe, because you can make so much noise with so many different objects.